systems. All right, so what is an LLM exactly? If you haven't heard of it already, it is a large language model. And essentially what these are is they are AIs that are able to recognize and generate human-like text. So for example, you could ask an LLM to write you a story or translate a book for you, or even ask it a question like, why is the sky blue? And it'll give you a comprehensive and human-like response. So I'm pretty sure most of you have already heard of ChatGPT, maybe Llama and Gemini as well, but these are all LLMs. So normally LLMs only do things one step at a time. So for example, you give it a manual input and then it'll generate a response, and then you can give it manual feedback on the response and it'll generate another response, and so on and so on. So this makes it rather difficult to do more complicated and multi-step tasks. So one limitation is that LLMs have set or limited context windows. And what this means is that they will only take inputs of a certain length. If your input is too long, maybe like you want to input an entire article or maybe an entire book, it'll just say, no, this is way too long and I can't do this. Another limitation is that LLMs generally struggle with longer inputs with multiple components. So if you want to give it a very complex task with multiple steps, it might miss some steps, or it might just not give the correct response at all. And in order to work around this, you can actually try agents. So what an agent is that it is an LLM designated with a specific task. So LLMs by themselves are single agents. Essentially, you can tell an LLM, for example, to translate certain things into French or from French to English. And multi-agent systems are many of these agents or LLMs put together. So essentially, the thought behind this is that two heads are better than one. You know that song. Having multiple LLMs work together is better than just having one LLM do an entire task by itself. In multi-agent LLM systems, each LLM is given a specific role and all work towards a common goal and task. So for example, let's say you want to write an email. For us, it's pretty easy. If you want to schedule an important meeting between you and your coworkers, you just have to, figure out everyone's available times and write the email and send it. But for an LLM, this is actually a very, very difficult task, as there are many components and steps that are needed to be done. So breaking down this general task of writing an email, first, you'd have to know everyone's schedules. You have to check their shifts, vacation times, et cetera, et cetera. And then you'd have to use this information on everyone's schedules to try to find a suitable time. And if there isn't a suitable time, you'd have to ask around, see if people can change availability or make some time to show up to the meeting. And then you'd have to actually write the email to everyone, make sure it's like professional, concise, and clear as you're sending it to your coworkers, and then send the email and wait for responses. So if someone has an urgent thing that comes up and they need to reschedule, you'd have to respond to that and perhaps change the time to a different time that works. So for this task, it's very, very difficult to do with just one LLM, as you'd need a very, very overcomplicated and difficult to understand prompt. So you'd have to say like, okay, first take this time, and then you'd have to find a suitable time in between all of these, and then you have to write an email. And if you get any responses, you'd have to revise the time, and the LLM would most likely fail. So instead of just giving it to a single LLM, you could give multiple LLMs separate tasks to work together to this common goal of writing an email. So in order to sort of break this down into different agents, you could have one LLM compile availability for everyone's schedules, another LLM find a suitable time for everyone, or say that there isn't one if there isn't any suitable time. And then you'd have another LLM write the email to everyone and actually send it. And then another LLM to comprehend and compile responses received by the people that were originally sent the email. So this is sort of a general figure explaining this process and how it would be separated. So you'd have an availability checker to actually process the times, and then send the times to a schedule creator, which would try to find a common time, or if there's no time that is available for everyone, send it to the email composer, which would then send an email to the coworkers, which would then send a response if necessary to the response checker. And then the response checker would be able to read the responses and see if there's any issues. If not, then everything's fine. But if there's any issues or any time conflicts or anything that comes up, send the information back to the availability checker, and so on, and sort of loop around until everything is good and done. And then you have a meeting time for everyone. So essentially what we do with these multi-agent LLM systems is that we break down tasks into separate components and then give individual roles to each LLM or agent and then connect these together. So usually this means having inputs and outputs of each LLM to feed into each other. And yeah, so it's very versatile and you can do it with a lot of different systems. And I have a bit more of a practical example ahead. So writing an email is pretty easy. It's something that everyone can do, but for systems where you want to have really relevant information and automatically process it, you could create an agent-based web searcher. So why we want to do this is LLMs are made by training them on data and then deploying them. So if you weren't aware, they actually don't have direct access to the internet. What they know is from the data set that they were given when they were trained. These data sets are updated and they are retrained on new data, but this doesn't occur like super frequently. So if you want more recent and relevant information, you're actually going to have to connect them to the internet. So in order to break this task down, first you'd need a question to be generated to search the internet with. So if you want to find perhaps any good restaurants in your city, you turn that into a query to send to maybe Google. So for example, top rated restaurants in Edmonton, Alberta. And then you'd actually have to physically conduct the search and read the site data. So you could maybe check TripAdvisor to see which restaurants are rated the highest, maybe Yelp or Google reviews. And then you'd have to compile this data and summarize it. So using all the information they got from the websites, you would be able to say maybe the best restaurants in Edmonton are blah, 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 blah. And an extra step is perhaps provide feedback to the response. So maybe in the person that originally set the prompt was only looking for Italian restaurants and they forgot to mention that, then you'd send that and it would be feedback and the search would be generated again, but only looking for Italian restaurants. And another step is perhaps using an LLM agent to actually automatically check the response. So this is sort of a feedback agent or a sanity checkers to see maybe the response doesn't make sense, or maybe the LLM just didn't provide like an actual answer to the question, and the feedback agent would then automatically say, this response doesn't make sense, try again, and provide feedback perhaps. All right, so in order to actually separate this into different agents, I decided to turn them into a planning agent, a search agent, an integration agent, and a feedback agent. And this is sort of what they do. So the planning agent would be responsible for generating search queries. It would then choose the most important query based on the search queries that were generated. And it would also take feedback from previous plans or queries, perhaps if the loop went back and something was wrong, and it would also be able to revise plans. The search agent would search the internet via queries from the planning agent and actually read and compile the site data, and then send the results to the integration agent. And then the integration agent would then summarize these search findings, perhaps say why it's insufficient if it doesn't actually answer the question or if there's missing info. And then the feedback agent would check the response from the integration agent and do a sanity check to see if the response is relevant, coherent, comprehensive, or maybe if you want citations, if there's citations or not. So to actually see this in action, we deployed it, we're working on deploying it on the rare disease chatbot project that we're all working on. So what this is it's a chatbot designed to handle any and all rare disease related questions. It's basically designed to make accessing info on rare diseases easier. Maybe if you're not a medical expert, but you still want to find some information on a rare disease that maybe a relative has, or if you don't speak the language, as most scientific articles are written in English, maybe you're French or Italian and you want to know this information as well, or also provide information to those with limited access as well. So maybe you can't access Google easily, or like it's banned in your country, you could also use this chatbot. So with this chatbot, we can use a set database for disease info, but there is a lot of information that needs to be highly relevant and updated. So if you want perhaps doctor information or medical center information, or you want to include information on perhaps a new medical discovery, you would actually have to connect it to the internet instead of having a set database that was made a while ago. So as an example, let's say that you asked the chatbot, are there any GNE myopathy doctors in Edmonton? This query would be then sent to the planning agent. And the planning agent would then generate a set of queries that can be used to answer the original question. So as you can see here, it generates GNE myopathy specialist doctor in Edmonton, neurologist specializing in GNE myopathy, and it sort of chooses the best one. So these are ordered in order of which one the LLM thinks is the most relevant. So it chooses the first one, and then that query is then sent to the search agent, which then actually conducts the search and visits the website. So as you can see here, the search query was the best one on the previous slide, GNE myopathy specialist doctor in Edmonton. And then it finds a website, Alberta Health Services, and visits it and sort of compiles that information. Using this information, the site info is then sent to the integration agent. And the integration agent summarizes the search result into a human readable format. So instead of just having raw site data, it actually writes it out in a proper response. So I could just read this here, the integration says, based on the information provided, the Chi Edmonton Clinic's neuromuscular and myasthenia gravis clinic in Edmonton offers diagnosis and treatment for neuromuscular conditions and diseases. While a specific mention of GNE myopathy is not provided, the clinic's services include information and support for clients and their families, neurological treatment and symptom management, telehealth services, consultation, et cetera, et cetera. The clinic's healthcare providers may include neurologists and registered nurses who could potentially assist with GNE myopathy, or if you prefer to, or refer to use to a specialist. And it provides the contact details, the location, the phone, hours of operation, and it also provides a citation at the bottom. So for more information, you can visit their website, K Edmonton Clinic, Neuromuscular and Myasthenia Gravis Clinic, and it provides a link to that. This response is then sent to the feedback agent, and the feedback agent essentially checks if this response is good. It's a little bit hard to read in the screenshot there, but essentially what the feedback agent is doing is to checking if the response is relevant, coherent, comprehensive, and if there's a citation and it says, yes, this response is relevant to the query as it provides information about a clinic at Edmonton that offers diagnosis and treatment for neuromuscular conditions, which could include GNE myopathy. The response is coherent and well-structured, providing clear details about the clinic services, contact information, and hours of operation. And it is comprehensive as it addresses the query by suggesting a potential place for treatment and includes a link to the clinic's website for further information. So this essentially passes, and then it would be sent as a final response back to the user. This is sort of a general summary of what it would look like. So on the left, the user would send a query, which would then be processed by the planning agent. And then the planning agent would send the plan or the query to the search agent, which would then compile the actual data from the internet and send it back to the planning and feedback agent. And this would sort of loop around again and again until the feedback agent or integration agent said, yes, this is a suitable response, and then it would pop out the final results. So yeah, multi-agent LLM systems in general are a really versatile and practical way to solve difficult tasks with LLMs that normally couldn't be done. But also, you can also use multi-agent LLMs to come up with solutions and that normally can't be done. So for example, if you have a really complicated multi-step task that is a bit too hard to fit into a singular prompt for an LLM, you could just break it down and have different agents work on separate components of the problem. Another thing is that you can plug in various types of LLMs, so you can use both small and large ones, popular ones, less popular ones, open source. You could also plug in your personally developed LLMs. And it also allows for less powerful LLMs to actually compete with larger ones. So for example, ChatGPT-4 is the most popular and probably the most powerful LLM right now, but you could use Llama, which is in more open source and free LLM, and you could use it, the sort of capabilities, and combine like it together to sort of compete with a larger and more popular LLM. And yeah, it's a really new and interesting topic, and it's actually being researched and developed on by large companies. So Microsoft is working on AutoGen, which is just a multi-agent system that does a wide variety of tasks. So it does web search, it does like story generation. I think it also does image generation, and it sort of uses this whole idea of making large tasks that are normally really hard into smaller pieces and having LLMs work together. There's also Perplexity Search, which is a really popular search engine, which is actually rivaling Google and ChatGPT right now, which essentially uses multi-agents to sort of augment search and come up with better responses that are more relevant to the original query. So yeah, that's my presentation. Does anyone have any questions?
Thanks so much, Carissa. Very, I think, informative. We learned a lot about, I think, LLMs now.
Mm.